Wastewater treatment is a widely explored industry. The company that we focus on is Littleton Wastewater Treatment Plant, which is located at New Zealand. This plant treats maximum daily inflow of 5,300 meter cube per day by using SCADA, which integrated with PLC as its control system. SCADA is an automated system that has both software and hardware that sources and control data from remote site. Frequently, SCADA used in control of material transfer from long-distance pipelines or in smaller applications such as wastewater treatment. Meanwhile, PLC runs a ladder logic program that controls the output of a system based on the input that is monitored. Although SCADA and PLC are integrated to the plant, efficiency and cost associated to the process control is extremely crucial. Sludge treatment is one of major process in Littleton Wastewater Treatment Plant. In mid of 1999, there was a problem encountered on sludge aeration unit where investigation revealed that sludge handling operation had order problem. There was a design fault with the method of keeping the sewage sludge aerated prior to the dewatering and transportations offsite. This problem was solved in September 1999 with new sludge aeration installed. However, the current operator believes that when the plant's operating well, it operates very well and expect no orders from it. But does the efficiency of the current control system affects the plant, and what improvement can be made to increase the efficiency of this control system? To understand further about the control system, we first need to know what SCADA is.
SCADA is used widely in many wastewater treatment plants today and for several good reasons. The first one is that it uses a centralized management control system which enables us to retrieve information and monitor and control the plant whether you are on-site or off-site through an online interface. This allows operators to immediately be notified should a problem arise in the plant, and this also helps them obtain the necessary information of the problem so that they can carry out the corrective actions. A SCADA system also is able to automatically collect data and produce reports and records. It converts the data into charts for easy analyzing, and it also is able to sound alarms when there are significant deviations. The recording of historical data is extremely important for problem solving in the future and also protecting the company. The readily available information can be used in case something goes wrong in the plant. For example, when there is extremely heavy rainfall, this causes the wastewater treatment plant to exceed its maximum capacity. In these situations, a lot of times operators are forced to carry out the emergency action, which is to just dump the sewage into the rivers. And this is definitely not a desirable choice of action, however it is necessary under emergency situations to prevent damage to the plant. To protect the integrity of the company, all the information stored in the SCADA system is now important to act as proof to the authorities that such an incident indeed occurred and the actions carried out by the operators were necessary. This helps the company to avoid the hefty fines and also maintain their reputation. Although SCADA brings many benefits, it also has areas where it can be improved. Firstly, it is a rather complicated system which includes PLCs, input-output subsystems, and also removed terminal units which spans the entire plant complex. A system like this could easily cost up to hundreds of thousands of dollars, and this is not even including the cost to maintain it every once in a while and the cost to train personnel on how to operate the system. The cost is a burden to a lot of wastewater treatment plants, especially those that are non-profit organizations. Besides that, SCADA also relies on wireless communication, which makes it prone to security threats. This means that it is easily hacked and manipulated. This results in the disruption of availability of information, the loss of integrity of the company, and also violation of confidentiality. A survey found that security threats caused 41% of companies to face reduced productivity in the plant, while 29% reported the loss of ability to monitor the plant through the system. And out of the plants surveyed, half of them reported a significant financial loss exceeding $1 million. A real-life case of security threat occurred in November 2011 when Russian cyber criminals accessed the public water facility in Springfield, USA, and managed to destroy a pump which supplied water to thousands of homes. Besides that, another real-life example occurred in Australia in October 2001, when a man was found guilty of hacking into a computerized waste management system, causing millions of liters of raw sewage to spill into local parks and rivers. This resulted in the loss of marine life, the creek water turning black, and there was an unbearable stench for nearby residents. Therefore, due to the large impacts of the disadvantages, further improvements should definitely be made to the control systems of wastewater treatment plants.
Sink control system mainly avoid accumulation from alkaline in the system, as FOG in sewage is harmful. Accumulations can cause it to congeal or harden in the major pipe blockage and sometimes leading to sewer floating. The suggestions that we would like to document is Environmental Decision Support System, EDSS. EDSS is an assessment that supports the complex decision-making process based on the integration of mathematical modeling as well as knowledge-based system. It has been developed for the identification and assessment of the most appropriate sludge treatment technology for the designs of wastewater treatment plants. This software is developed based on the 6 steps, which is the problem statement, data collection and knowledge acquisition from the remote sites of SCADA, development of an integration model from the system, knowledge-based development, integration of EDSS and implementation. The EDSS can be structured in different models in order to allow the interaction between the system and the knowledge of the person to provide optimal actuation to the end user. The final step will be the application of EDSS. After that, the effectiveness, operation cost, and environmental criteria can be compared to the performance of the traditional approach, which in this case is SCADA.
EDSS system has many functions that are with higher efficiency when compared with SCADA. Its software, which is Novada EDSS, will not only control the effluent, which is the input compositions, but also the effluent of the water treatment plant. As engineers, it is important for us to consider the sustainability of the system and the environmental impact of the wastewater treatment plant. Novada EDSS will also store the sub-products obtained from the treatment with detailed data, which now can be used as biomass products, which will be another selling product of the plant. It will generate information on the investment money required to proceed with this process beforehand and the cost required for the entire process, making EDSS a cost-saving system. Being able to control the type of operating needed for different compositions are also one of the advantages of Novada EDSS, as it now reduces the order and also improves the sludge treating production. Novada EDSS can also increase the plant performance warranty by removing the emerging contaminants and reusing the effluents of biomass. Reduction of chemical consumption, nutrient removal, optimization of costs, simplification of plant operation and labor are the multifunctions of EDSS, which now gives a visual impact on products and on the environment.
As conclusion, Littleton Water Treatment uses SCADA as their main water treatment plant monitor. Its associated software, PLC, operates ladder logic program in which control the output of the system based on input monitored. Although its function is to transfer materials through pipelines and small-scale application, it also faces challenges on order and composition. Besides that, the major concerns were on security that could be a threat to sabotage and defamation. The suggested improvement by our team is to use Environmental Decision Support System, EDSS. Its function mainly on making decision for the user by applying knowledge on any action taken and also its alternatives. This will increase the productivity of solving order problem and also reduce threats by using their software, which is Novada EDSS. EDSS also provides user with investment and operating costs, as well as direct and indirect GHG emission of traditional sludge treatment. The company now can identify and evaluate the best sludge treatment technologies.